Hey, Tony. Hi, Tony.
Hey, David, how are you?
Good. How are you?
Good.
Hi, Tony. Hi, David.
Hey, Bala. How are you?
Yeah, I'm doing good. Thank you.
As usual, let's give everybody a couple of minutes to trickle in, and then we'll get started.
Okay.
Rajesh, hi, Boom.
Hello.
We are waiting a minute, and then we'll get started. Okay, I think we should get going. Today's agenda is test design kit. First, I wanted to see if there's any updates from any of you.
Yeah, I have made a block diagram for that the GTK development. So this is what I have been discussing with the internal team also, like with Tony, Pathius, and others. Um, So I have also offline discussed with Vikas like a couple of weeks before. At that time, I did not have the block diagrams, but we verbally discussed like what we can do with a limited availability of the resources and things like that. And then this is what I have shared him verbally, and so he's kind of aligned with this proposal. And so I'm waiting to discuss with him and waiting for his availability to go deep dive. And so we might have to slightly modify this proposal, like with like plus or minus addition or deletion based on the people's inputs. So right now, conceptually, this is what we can do, right? Where
So, Bala, this is very Siemens specific, and I haven't made the last several calls. What are we trying to do in this?
Yeah, so I have given an example based on the Siemens tool here, like, but we have the capability across the other tools also, Tony.
What is the
So,
overall flow here that you're trying to demonstrate?
okay, so there are two things that we can achieve today, like based on the package collaterals. So for the DFT verification, so there are two long poles where today the DFT designers are lagging behind the help because of this lack of EDA tool capabilities or automations in this space. So one is on the boundary scan. This is the first column that I have mentioned, where there are lots of manual efforts going on in defining the pin order file. Also for the SKU variants, like selecting the across the segments. So this is a multi-scope profile, Tony, where each SKU will have its own set of interface on the IO side. And
When
then
you say SKU, is that each chiplet, you mean?
SKU is um, it's a package bonding options, like where there are let's say, for example, Intel, right? So they have multiple DDR interfaces uh, in the originally in the design and in the package level, but then they have a fuse variants, like they can, for different customers, they can bond in or disable some fuse configurations. So some fuse files are disabled and the IO is also disabled.
So this is, yeah, I know in the old days, we had bonding options, so you could have different, I guess.
Right.
Is this for binning purposes or is this for different pinouts?
It's for different pinouts, like different customers, they might choose DDRs from the different direction of the package. Like somebody might prefer left side, somebody might prefer the right side interfaces. But
Okay.
yeah, that is based on their PCB design, right? The the platform design. Uh, so the so for that, Intel has this. It's their bread and butter across all the data center products. Um, it's not only the DDR, all the high-speed I/O GPUs, they have the same flavors. And so with the BSTL, with the 2013 standards, it gives an automation facility through the standard, through the like creating a segment BSTL, right? So for each 5 segments, you can create each 5 interfaces, you can create a specific segment or more than one segment in some cases, right? But that allows the pattern generation tools to configure on the fly, but then it also needs some modification on the BSTL file by itself, because the BSTL file will define all the IOs, naturally the master BSTL, but with the SKU BSTL, where you have some of the IOs are gone, and so we need to tell the tool like those IOs are not really participating in the boundary scan access kind of things. So the tool tries to generate some patterns with the incorrect BSTL definition in that's in those cases. So
So
what?
this is in functional mode,
Yes. Yes, so during the
and
power
it's
platform,
really just for like for FIs for
right?
okay.
So the doing the platform power on, like a BS, like X test with a BSTL boundary scan test, that's one of the primary baby step test case that any customers will do during the platform stage. And that is the same test which is also applied on the um, the high volume test bring up, right? But it won't go into the production, but the bring up sanities that they will have it whenever they have a newer pinout or a newer variant of the wafers, they will have these tests called, right? So it is solving the both the purpose, like for both for the manufacturing as well as for the customer's platform bring up, right? That's where this task is very crucial, where the I3D kind of package design tools, they have the capability to generate this connectivity CSV and the stack level netlist at the package side and def. But but based on this information, this pin order file is manually being created today, right? And then the SKU is another fuse variant. So it's which it dictates how many segments are alive and for that particular pinout, and how many are disabled, right? So that also is being manually processed, right? So then in some of the scenarios, even the platform, the ball numbers also changes, right? There are different variants customer the package designs handles. There are low cost variant and high cost variants, and so in those cases the ball number also changes. So that way you will see there is a tremendous number of manual efforts is going on, and it creating it. Like, so I have worked on Intel data center product. One product I landed up in creating a Perl script, and for all these SKU variant whatever it needs for that particular device. So I had ended up in generating like 1200 plus BSTLs out of Apple script. Right.
So this, how does this tie into TDK?
For the TDK, like so they would come back and ask for this type of help, like where there is no EDS support for this orange box today.
Right. So you're saying the test kit would be able to, is this for a chiplet, or is this for a packaged part?
This for the package part.
All right.
Yes, with the TDK, like we can define these are the needs, and so
I thought, I haven't looked at this in a while. So I thought TDK was targeted for a chiplet. Is that right, David?
Yeah, that's what we were thinking, but right, again, right, defining it for a chiplet and defining it for a package part, I think should be about the same, right? Because that goes into the next level integration, right? And chiplet could be, right, if you think about it, HBM is actually a chiplet, but inside it's actually a package part. So probably it's somewhat agnostic, should be agnostic.
yeah, so even for the chiplet, Tony, like so we need to define like what are the receivables from the chiplet, right? To involve these type of package level activity as a collaterals. So chiplet needs to be told like, okay, as a requirements. So you need to provide not only just the BSDL, also your SKU variants and what are the segments for each of those SKUs which has been alive. And
So, David, you know what BSDL is, right?
Not exactly, but
Right.
very vague idea.
Well, I'll give you my layman's description, and Bala can correct me if I'm wrong. But it's typically a set of patterns that's used for board level testing. And it's really just a set of patterns that will toggle the IO, all the IO buffers of the device. And essentially, you can run board level patterns to make sure that you have access to all the IOs of the chip. It doesn't go inside the chip at all.
Okay.
Okay. So now when you have multiple chips in a package, it's a different problem, right? Because, if you have 5 different chips, your primary IO is hooked up to a bunch of different chips, right? So,
Right.
And there are tools and workflows that will effectively, once you put this whole thing in a package, will create a BSDL. So the board level, you can test the IO to your SIP. Let's call it a SIP instead of a chip, right?
Okay.
So the way I think we should think about this, and I'm open to discussion, but how you do this BSDL in the DFT flow, you need some information about the chiplets, right? So if you're designing the whole thing and you're doing the DFT insertion of every chip, then the tools can support that. It's kind of like a hierarchical design. But if we treat the chiplets coming from third parties, we still want the ability to create BSDL for the SIP. So the idea is, what information do we need for the chiplets in order to enable the test engineer to test the part, in this case, to create BSDL for the part. So so the idea is that this TDK would be the information in the chiplet relating to it's primarily the test IO, and there's other stuff that we put in there. in other information and properties or whatever. But the idea of the TDK is to provide, whatever collateral is necessary to enable a SIP DFT engineer to test this chiplet along with other chiplets that he may be designing himself, or they could all be coming from third party. So having said that, Bala, does it make sense to have this information for a chiplet in the TDK?
Okay, so this is more of this deep dive information for the SIP DFT person, but as a chiplet deliverable standpoint, like maybe we can dictate just as a instead of a flow, like we can just say a requirement list, like what chiplets needs to deliver, like if that sounds good for us.
We're not developing flows in the TDK, right? So we're providing information that end users can build their flows.
Okay.
So can we create a spec? Does it make sense? The first question is, does it make sense to provide some configure information on a chiplet that would be put in this TDK that would be the necessary collateral that your top level test engineer would be able to take that TDK for each of the chiplets and create a BSDL. Now the test is a lot more complicated, right? Because you're not gonna put like patterns in a TDK, right? So the idea is we're defining the test IO. So how do you test this part? Here's the pins that you're going to need to test the part, and then there's some set of scripts or patterns that would need to be delivered with that chiplet, right? And that's something I don't think we want to put in our format. We should use industry standard formats. So I think it's the ICL stuff, right? So it's just a file, right? And that file, I guess, needs some configuration information. So the configuration information, I think, is what we want to provide for the chiplet. And when the customer buys the chiplet, the chiplet vendor will probably just send them those patterns. Those patterns are pretty sensitive information. They need to be encrypted. However they want to deliver it, I don't think those patterns are going to be very big. So that's something I would not envision you're putting in the JEP 30 model, although in theory you could, but I suspect it's probably not practical or even safe to do that. So again, does this make sense? And what specifically does that TDK look like? How would we can we create a spec for what's in that DICL? This flow diagram should show how the user would use it. And I think for CDX we want to be generic, so we don't want to use our tool name, so we should replace it with but that's fine. This is our flow, and we can change that later. But let's focus on the TDK. Is there a section of the TDK where it makes sense to put information that would be provided for the chiplet to enable your SIP designer to create?
I
boundary scan. That's the question.
I think the one other way to phrase this is when you get a chiplet and you get all the files with it, right? All the deliverables, what what needs to be in the data sheet, or what is in the data sheet right now that people have to go and read to enable their next level DFT instruction flow?
Well, I mean, the only chiplet that I'm aware of today is a an HBM, and those things have a very fixed, rigid, IEEE spec that defines how to test those parts. So although it is a chiplet in a sense, it's not a general purpose chiplet, and it's a very simplified, it's
Yeah,
a very specialized subset. So we're trying to come up with a format that would be for any general type of chip that's going to use traditional, your traditional structural DFT patterns.
yeah. I guess the inverse question of that is, when a vendor is delivering a chiplet and they have all the patterns, all the test inserted stuff, uh, what additional information they want to convey that is not available in any of the formats? Something about integration or pin definitions, things like that, which a person would need to go and read and input into tools, right? That's the part we want to carry in a digital format that can be
Right.
read by tools. And I guess that's a question for both you and Bala.
Yeah. So there's kind of two dimensions to that. One of them that is in the 3D block spec, and in fact, I would argue that's the only thing that's in the 3D block spec, is basically the wafer sort pins. What pins does the OSAT need to test the part at wafer sort test? So that's one thing, and that's pretty straightforward, right? That's
Yes. Yeah.
simple. Here's all the probe pads. It's a list. You have the XY coordinates, and there's pin names, and then there is, a whole set of collateral that you would provide. Typically, I don't think SIP integrators are going to be retesting wafers, right?
Right.
So the wafers should be, I would anticipate these wafers are going to be sorted by the wafer provider. Now, it is possible that, maybe not, right? So maybe it's an unbumped wafer and you're doing some post-processing layers, and then, that whoever's doing that, back end line stuff would then, and one approach that I've seen is, for hybrid bonding type devices, uh, practically speaking, you can't bond those. So one way of testing those is you can basically, do a buildup, and basically just post-process the wafer, deposit a bunch of probe pads, test it, and when you're done testing it, strip that away.
Yeah.
So that, in that scenario, we would, the that raw untested wafer, that would be kind of an internal deliverable between the wafer provider. It's basically an untested wafer. So
Yeah.
an OSAT or an assembler, it typically would not be the design team. It would be kind of that OSAT, the assembly and test house that would generally get that information, right? So you're going to give them, a specific test program that runs on that for that chip, and they're going to run that, but you're not going to give that to the end user. The end user needs the ability to test once it's in the package, And so I think the only thing we need to provide for wafer sort is, what I said, just the pin out, and then that's it. But there's a lot more information that you're going to need to provide for the chiplet in order to be able to have test access to that, and figure out how you're going to, test all the devices within there. So that's where you're going to have to, use this. We call it tested multi-die, but it's another set of tools that allow you to basically stitch together to be able to test all these things from whatever pins are available coming out of the package, right? So ultimately, you only have access to the pins coming out of the bottom of the BGA, and somehow you need a methodology that gives the end user the ability to test every chiplet, the interface in between all the chiplets, and maybe some system level testing, that kind of stuff. And again, there would be kind of a some type of mechanism where you'd have to provide, the patterns, or that unless it's totally BIS, then you just run it and you get a pass fail. You would need to provide some kind of patterns that are going to do the different types of tests. So I think the way the industry is going is you're pretty much using IJTAG to test everything. So it's really just, at least for a 2.5D, you have a handful of pins, and you can test that entire chip by running patterns through that JTAG interface. In standalone chips, you can multiplex the SerDes and have access to all those IOs, but that's not really a luxury we can do unless those pins are going out. Well, actually, if it's an external SerDes, those pins are going out of the chip, so in theory they could be used for testing if you put them in a bypass mode.
Yeah.
But the die-to-die interfaces, you don't have direct access to those, through the pins. But there's techniques that are kind of generating patterns that on each of the chiplets, so you could test those interfaces. And most of the IP vendors have kind of BIS type testing where they can test all that stuff. They're kind of built into the PHYs, but most, but not all. So
okay.
So,
Yep.
yeah, Tony, when I created this flow diagram, right? So I have made the in the interest of SIP level DFT activity, where I have highlighted just now, like with all the red color fonts, where these are the manual efforts which is going on, and which are most of the time these are the iterative efforts, right? So I think even if we specify the TDK with the chiplet level requirements, so we can highlight what chiplet BSTL needs to deliver for the SIP DFT as a requirement, but we can also give a full picture of this flow so that the chiplet DFT is given some sufficient information about, okay, what are the other churns are involved in the SIP level DFT, and so that they can procure right number of test plan and assess and coverage group, right? So all those validation get highlighted for them to put more emphasis and the resources on that for the chiplet deliverables. Right.
Yeah. So, and this is very hard to read the diagram. It's very small, but where is the TDK for the, so you have a bunch of chips that's.
So this is
guys,
the BBS.
Guys, sorry to interrupt you. I see that Rajesh has raised hand. Maybe give him the floor for a moment.
Sure.
Hey, thanks, David. So Yeah, I had just one comment and one follow-up what Tony said, right? I mean, this rightly pointed out about TDK, the purpose of TDK is, as explained earlier, provide the information. This, what flow diagram, Bala, you have put looks like a capturing the
It's
tool
capturing a
flow.
test flow, right?
Yes, flow. Yeah, I mean, it's TDK has a different purpose because I think what David, as we collaborate on CDX is the purpose of gathering the information and just give the what needs to be done. We are not supposed to be doing it, but as you mentioned, Intel used to have different SKUs. So my comment was, this is not anything different from they have been doing for years. Only difference may be the package because now we are going 2.5D. So I think whatever the inputs coming from left side in your diagram, BSDL, different chiplets. Now they are called chiplets. Earlier they maybe used to be called some packet chips or whatever that Intel does internally. And I've seen even in Broadcom SKUs, definitely how you bond in the package level, they can have different parts with the same chip inside. So this is known problem about bound scan collateral generation. And if you take the Tesson 3D proprietary in them out, I think every vendor should be doing it through some mechanism. Right?
Right. They like the point is like today everybody is
So I don't have a
doing.
problem in showing the SIP level flow. Oh, sorry. Go ahead.
Yeah, SIP level flow is what also maybe custom to each particular EDM or whoever, AMD, Intel, they will have.
Yeah, so I
What?
think, you know, at the SIP level, we need to show a generic flow on how
Yeah,
those files would be used. So it shouldn't be
correct.
specific. So we need to kind of generalize, you know, DFT or BIS tool, whatever, you know, just refer to it as the step in the process. But you know, it should be tool agnostic, where you know, and I think in order for this whole ecosystem to work is, you know, we want to use, you know, standard IEEE methods and standards, right? So we should reference the specific standard and, you know, rather than using a vendor's proprietary, you know, secret sauce, because that, you know, they can always do that, but at a minimum, we need to make sure that, you know, you support the basic standards, right? You can put in extra stuff if you want, but you know, we need to make sure that that any chip provider is, you know, needs to, and we did put that list of, you know, in our CDX original paper, you know, what IEEE standards should be used for the chiplets.
Yeah, and one more comment was, I think with the beginning when the TDK, when David and we were discussing, he gathering the information about all that pad stuff and all that stuff. The only difference I see what has been done and what needs to be done is complexity is going to increase, as everybody knows. So maybe that may be the added layer of complexity. Yeah, if you have 1838, then you can mention that. But TDK, I think that is the main challenge. That's what I see for providing the more complex information. Otherwise, this is a standard diagram which you're showing, Bala. I think there is no difference between 2D versus 3D.
Right, from the boundary scan or even ATPG perspective, right?
Yeah.
The stack is just the connectivity across the chiplets, right? So,
Correct.
where BSTL absorbs that layer. So the way the SIP BSTL is being created, and I'm trying to highlight there are some headaches involved because of this the segment info and the SKU infos, right? And then the pin order and the pin, the different bonding options, the bond numbers.
Yeah.
So all those things are today it's been like handled through the custom scripts from each of the semiconductor companies. Right. So we might have to
Right.
like
So,
articulate that information in a
all right.
in the right manner.
Yeah. So I think if, maybe you can create a little snippet of what would be in that section of the TDK, create a very simple, chiplet, and then, kind of a little cartoon of the chiplet that shows the IOs, the test pins, and how that information would be captured in the the TDK format.
Right.
Right.
Yeah.
And we only have access to the pins, so the micro bumps for a standard chiplet, or hybrid bond for a a hybrid bonding type of device. So it's going to be a micro bump or whatever. Now you also have the ability to verify silicon interposers, right? So if you have say 2 chips that are assembled on an interposer, you can test those chips through the interposer that's making those die-to-die connections. And in fact, that's something that we supported when we were doing a chip with HBM memories, and that was a very simple case where we had one big chip with 4 HBM memories. So what we would do is we would assemble the chip, mount the chip on that interposer, and then test to make sure that chip was assembled correctly before we would populate it with all the other HBM memories. So that's kind of a if you had a defect, let's say on that device, maybe running at speed testing on that, and rather than, so you'd still have to throw the port out with the interposer, but at least you're not throwing 4 good HBM memories away. So even in the TSMC spec, they support kind of top side, bottom side. So their format allows you to kind of the probe pad could be at the C4 bump side of that interposer. So Bala, I don't understand what you're trying to do here in enough detail, but based on this conversation, is there something that we should include in the TDK to support SIP level boundary scan? That's the question. And if so, we need to articulate that and show some diagrams and maybe some simple snippets of what that would look like.
Mm-hmm.
Yes.
Okay. Yeah. I can. Yeah. Now I understand the picture with respect to chiplets, right? So.
Okay. So
yeah,
you want to think about that? So it sounds like you're not ready to answer that today, but I think that's what we should think about. And if you think it does applicable, if we could have something to discuss in our next meeting in 2 weeks, I think it would be helpful. And again, knowing what that top level flow looks like will be helpful to describe how this is used. So that's important too, because this, there's a very small percentage of the whole design ecosystem that understands tests. So we need to kind of describe it at a high enough level where, somebody like me who's got a very rudimentary understanding of tests gets the basic gist of it. But you know, an expert DFT person, it would be, yeah, that's obvious what you're doing here. Yeah, that's a good idea, kind of thing.
Mhm. Okay, sure, Tony. Yeah. And so this is one of the problem statement. The other problem statement is um, there are some IOs which are tested through the die-to-die interconnect test using the ATPG test. So that is the second area. And then there's uh, like understanding the coverage attained by the boundary scan versus ATPG and doing the fault grading is the last bucket, right?
I'm
So those
sorry.
are
Is this the 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 manufacturing fault type testing of the die-to-die interfaces, the stuff that comes out of the using the pin locations?
right, right.
So
So the
what is that? The physics? What do we call that format?
so so we call that as a placement of our ATPG pattern generation for the inter-die interconnect pins. So that will be utilizing
Now, is
um,
that an IEEE spec? Is that an IEEE spec or a TSMC spec?
so we yeah. So TSMC spec is comes as a 3D blocks where it gives that the BMAP files for the bulk map of the RGIOs, but then we have internal tools to generate the UDF form. Like it's also like a doesn't specific format. So I believe like each company they have their own formats.
What, what's the format?
The UDF form is a user-defined default model. So Tessent has it's a text file.
So user defined. So
Yeah,
user.
defined default model. It's kind of a JSON kind of format. So Tessent follows this across the different ATPG bundles, like Celaware and a regular ATPG also. Like so, this
Is so this is not an IEEE.
no, yeah.
Um, do other, does Cadence and Synopsys support this?
I think user defined is supported by all main CAD vendors. Everybody may have a proprietary format, but it's like Celaware or user defined. But my question, Bala, is
Well, is this UDF?
yeah, UDFM is I think
Right,
doesn't
but my question
name.
is, does 3D blocks have a format for this UDF?
I don't know. I have no idea right now.
No, it is not related to um, um, the package design at all. It's full of the format. It specifies the virtual RC um, delays between the IOs in terms of it gives an abstraction level for the tool to say that there is a potential victim and aggressor scenario. So this is something similar to like what you use like SDs like a SDF for example for the timing annotation. So you use the netlist for the logical and then timing through the SDF, and then the tool annotates both of them together and then creates and identifies that critical timing paths, something like that. So UDFM defines a virtual path between the IOs, which are neighboring IOs, and it models that.
So is this something like a delay kind of
UDF
information?
is a format that we created and hides the X, Y coordinates. What?
Yeah, it provides that this.
So the way I understand it, you put a chip on an interposer, right? It will basically the format just gives you all the pins that connect to that interposer to the chiplet. So if there's say 1,000 pins on one HBM interface, you'll get the XY coordinates for the chip and the interposer. So you know that those pins are physically connected. And by knowing physically where they are, you can look for like bridging faults. So you can develop some patterns that are looking for a short for a pin that may be 2 or 3 pins away. So it's just providing information that the test engineer can use to define their custom defined models. So I think that's a proprietary format that we have. I think it's a simple CSV file, is it not?
It's a text format with
So it's a text format. So what
right.
we just, instead of a text format, we put that in an XML file as a company. If they're doing something like this, they may have their own text formats, and so this would be a way of hopefully standardizing on a standard way to represent this in a single file rather than everybody having their own custom flows.
Okay, so thinking about that, if it's just XY coordinates and pins, that's already captured as part of each chiplet definition, footprint definition, and then the assembly, right? What goes where. So technically, that information already exists, right?
It exists, but the DFT scripts are not going to be able to read a complex assembly type of things. So this would be, it could easily be generated from that assembly stack and die information.
Yeah, exactly, right. So that's, I mean, the information for that already exists, not necessarily in the format you want. So there's definitely a conversion step, but that information, if it's X, Y, and
well, you're right, because that wouldn't make sense, because if it's just for the chiplet, then the only thing, you don't know what it's connected to, right? So yeah, it's a good point. So I'm not sure this makes sense to put in the CDK. We know the die-to-die interfaces, it's basically just the PHY and UCIe is what we're supporting today. And we're identifying that as an IO, and we have the XY coordinate. So the information for that flow required from the chiplet is already in that die model. So so this does not make sense then to put it.
Just to make sure, Bala, you mentioned something about RC delays and things like that. Is that part of the file, or this is basically something that as Tony mentioned, the DFT tools will be looking for possible aggressors, victims, and shorts and things like that, and just purely the information is XY pins and connectivity.
Okay. Yeah. Actually, I misspoke. Like not the RC the bridging, identifying the bridging fault based on the placement information of the neighboring IOs, right? So so that it will artifact as an based on the bridge effects, right? Based on the neighboring RC parasitic effects.
Yeah.
Okay.
So I think we agree this does not belong in the TDK for a chiplet, right?
Well, yeah, it definitely not for a chiplet. Right, the assembly instructions are already in the format. The chiplet information is already in the format, so definitely this information can be derived from there.
Okay.
Yeah, David, I think that's I agree because this UDMF is just one fault model type, right? So it doesn't belong here definitely, because it just completely goes into DFT domain, which has nothing to do with TDK. So otherwise, you will put all other fault models also, like delay fault model or stackad, or so that's not the. This is not a place because all the information is derived and fed into the DFT tool from all your X, Y, as you mentioned earlier. That's the correct source. So
Yeah.
I think I agree with you.
Okay. Sorry about this. Looks like it's already it exists, and it's the information exists. It's a matter of automating the creation of this, which is a good news, I guess.
Okay, yeah, David, yeah, I agree with you.
Yeah.
So I think now I have got some more understanding of this the TDK requirements. Like I think I need to look at that. Is there a TDK requirement sheet or something? It's been published, like where I can better educate myself. So
Yeah,
instead
we
of
do have that, David, right? Is that in the meeting invite, the TDK, the URL?
Yeah, in the meeting invite, we have a link to the CDX folder, and the TDK is in there. TDK is part of that. But really, I think, Bala, you have seen the TDK 1.0 that's in there. That was our first step. Just the overall idea for all the design kits is we don't necessarily define the design kits do not define a flow. The design kit is meant to capture information to enable those flows, right? And
okay.
specifically, as I mentioned, right, there's a lot of stuff that is being put into PDF files, emails, PowerPoints, and things like that, right, with numbers, right, specifications. We definitely want to automate that. Basically, where the step where a vendor gives a chiplet vendor gives the integrator the chiplet in a PDF file, and then the integrator takes the chiplet and reads the PDF file and reads the numbers and populates them in a tool. We want to take that information and put it into a file, right? So that there's no errors, mistakes, and this is fully automated, right? As humans, we have much better things to do than reading documents and extracting numbers and putting them in a tool, right? The tools should be able to do that. That's
Okay.
right. So as Tony mentioned, probably that's exactly what we need to look at is what information does not exist anywhere and exists only in a text format. I'm sorry, in a PDF format. That information we can capture in a file, right? Obviously, we're not going to capture the BSDL itself or the patterns, right? These exist somewhere. There is IP exact that defines the packaging and telling you what files are where, right? So if that is missing in IP exact, specifically identifying the BSDL, we can go and ask them to add it, right? But it's already set up to do I'm gonna use the word packaging, but what I mean is like a software package, like like collateral package for a product, not as a package for a chip, right? It's the right IP exact deals with the collateral packaging, telling you what's where the GDS files are, liberty files, constraints, things like that, right? We don't want to replicate that unless we have to. I do see though, as you were mentioning, the requirement for SKU segment info, right? The segment information. That's a straightforward to put it as a requirement, right? As a checklist saying is the vendor providing segment info or not? I mean, is the vendor providing the segment info or not, right? That's an easy step and easy change, right? The question is what's beyond that.
Okay, so there are two aspects with that, right? Actually, the SKU info comes from the designers, like the who's involved in the defining the fuses and also defining that partitioning the IOs, right? So that comes more of an architect kind of a persona, and but the segments are defined by the IP owners and the DFT integrators, like how they you utilize them. But then the mapping between the which fuse controls which segment, that is kind of a hidden in the data sheet, right? So those information has to be well documented, and it has to be provided from the chiplet owners, saying that because the manufacturing owns the fuse values, but they don't update the data sheet for this particular SKU. These fuses are enabled, kind of things, right? So then the boundary scan is really in the trouble, where the BSTL generation person at the SIP level, he doesn't know um, which fuses affects his boundary scan on which manner, right? He needs to be told, okay, these fuses corresponds to these segments, you need to disable them.
Okay, is that fuse identification standard? Is it I mean how they're named, or
Yeah,
what in
it's how they named, and also which fuse location they are programming it. And so ideally the platform guys needs to have this knowledge of um, like which of the fuses are controlling these IO segments, and read those status first, and then make sure that the BSTL segments pertaining to those fuses are configured properly,
okay.
right? So that's a primary baby step that SIP level DFT guide needs to be worried, and because this involves manufacturing and then architect and then DFT personas from the chiplets perspective.
So just in general, those fuses can be used, for many different things, not just test, your, now some of those fuses are just programmed at wafer sort, and for like a binning or something, and then some of them could be run in the field, right?
Um, I'm not sure if there is any field specific fuses for this particular topic, but
Well,
of course there are other fuses.
I mean, it's up to the chip designer whether or not they're just used for their own purposes. When they deliver the parts, to do different product SKUs to their end customers. But there may be some programmability that they can allow the end users to do it once it's in the package, right?
Mm-hmm.
Mm-hmm. I know we've done that in the past. And I can't think of an example at the moment, but PVT sensors, you have the ability to program those, but they're for a calibration mode. But yeah, that's usually done at wafer sort, but it could be done in package, right? Because but in general, there may be a need to have provide either the OSAT or the end customer the location of the fuse pins and some kind of mapping file that says what they're used for.
Right.
I don't think there's any standard way to represent that information that I'm aware of, right?
Yeah, so those are hidden in the firmware code, Tony. Like so, the firmware guys, they will know, they will have an access to all those fuse addresses, and tell the platform team or platform test team like which fuses for that boundary scan purposes are enabled or disabled. That's how.
So, but who who firmware and burns the fuses? Is it the
Manufacturing team.
it's the manufacturing team?
Right.
Yeah, so that's something you're not necessarily going to want to provide. I mean, if you have an OSAT doing the testing, you need to provide that information to the OSAT, right?
Right.
And then if it's something you want to provide the end user, there may be a bunch of utility where, you know, there may be bidding that you want to do after it's packaged, right? For whatever reason, you know.
Yeah. That may be a rare scenario, like, but yeah, you say, but
Yeah.
that possibility exist.
Yeah, but so we are supporting, you know, there's two modes, there's two usage models, right? One is for the OSAT, you know, the assembler who's doing the testing and assembly, and then the end user. So we need to provide information for both. Some of the information is, you know, so I would say there's a CDK that is strictly given to the assembler for the OSAT, right? And then there's a separate CDK that would go to the end user, where, you know, the end user may not have as much access to test pins or these fuses or whatever. So, you know, if it's just pins for the fuse, those are pins that I guess, you know, do we have a fuse mode, or, you know, is that just the mode that we can adapt for the just add to the, right? Because we do have every pin for the chip is defined in the physical model. The TDK has every pin which is used for test, and there's multiple modes. So there may be 10 different test modes, right? So in test mode 1, here's the function of all the test pins. In test mode 2, here's the function. So that's information that we want to put in the TDK. So the in those different test modes, those pins serve a different function, and that's something that we can you know, put in the TDK. Is that in there today?
That so identifying the pins by mode, that's there, right? It's that's the thing we talked about last year. That's there in 1.0
Yeah.
version.
So we could
as far as
a fuse program mode and just have a subset of pins that are used for that. Then, you know, you need to provide patterns and instructions on how to use those, but at least in the format we have this information, right? It's
I think
necessary,
Tony,
but not sufficient.
what I think Tony, what Bala was thinking is next level, where
Yeah.
basically what the information is here is a fuse location. I'm not sure how location is represented as an instance or as a number, or right, but anyway, right. Here is the identifier for the fuse, and for this segment
Test
for,
guy
for right
he just
for
pins.
right for this segment, the address X of that fuse needs to have value Y. All right, Bala, did I catch that correctly?
Right. So this is the fuse ROM address location, which corresponds to a particular PHY IP instance.
Okay, so I think the first baby step is to define a fuse. What does that mean? How do we identify a fuse? Then together with address, right? And then for the then associate those with PHYs and say, hey, here's a segment this segment, for this segment, that fuse at address X needs to have value Y.
Right. Yeah.
I think, Tony, that's the next step, right? Defining, that's definitely something that falls into the realm of what CDX is doing, right? Because it carries that information out of a paper data sheet and puts it in an electronic format, and then the test pattern tool, right, needs to go and, right, if you try to generate the wrong pattern, it's going to tell you, oh no, you can't do that, right, because the value is not right.
Yeah.
Or when you try to run the pattern.
Yeah, and you're going to still need information, right? Some of these fuses, there's a whole, you have to step up the voltage and do it. There's a whole sequence that needs to be done to program those fuses. I don't think that goes in the format. We just need to know the pins and the mapping, and then there's a set of instructions, which I guess we could provide an HTML document that describes, how those fuses are physically programmed on the tester. But you can't just give the pins and that's it, right? There's other.
So yeah, the fuse blowing is another topic, Tony. Like, so for this validation effort, like what we are looking at is, normally they have a address mapping of two different location. One for blowing the fuse, where they call it as a write address for that fuse of that IP instance.
Right.
And then there is another read address that they say that after blowing, they come back and read that particular fuse value, and then see whether it is fuse already blown or not. Right? Those are two different address locations. So what for our boundary scan purpose, we are primarily interested on the second address scheme, where the read address location, we want to ensure that if it is already enabled, that phi is existing, right? Then we can run this particular pattern for that phi.
All right. So just one last comment. We're over, and I do need to go, but I think some of the stuff we're talking about now is a little more esoteric and more advanced. I think these are things that we can add later in the spec. I think we need to really focus on getting the bare bone functionality, so we have a usable spec, get that in there, get it adopted, and then I'm sure there's lots of other things we can add to it. I'm not sure we have the basics there. And David, you said 1.0. I've read that. Is that the latest spec and it hasn't changed? When's the last time that was updated?
That was updated in so that is the latest spec. It was published in January. So I agree. We need to
and what's the status? Is that has Michael started entering that?
I don't think so.
Okay. So
that's
all right. So we published a spec 6-7 months ago, and we haven't done anything. So either we say it's good enough to go, and or we need to, what is our MVP, our minimum viable product, right? What is the baseline spec? I think we need to get that out, publish a 1.0 and say, this is it, open it up. Is this useful? If Michael takes to the JEDEC, it's, it'll be months of discussion. So we're going to have to, make sure it can stand on its own, and we can build on that later. But it seems like we really have not made any progress since January.
So
we have to decide.
Right. There's two sides to that. I don't know what Michael's plans are when to start adopting that. And maybe that he is not here today, but if he shows up tomorrow for the demo design meeting, we can talk about that. So really the question is, does that test 1.0 that was published by OCP, is that sufficient for Michael to proceed forward, or do we need to add more stuff?
That's the question.
Right.
That's the question. Yes.
The way I was
I think-
thinking about that is that the test 1.0 that we published is sufficient for Michael to proceed forward. And right now we're working on the next version, test 2.0, that's going to have the additional bells and whistles. Right. The test 1.0, right, apart from the simple pin function definition and modes, I think it adds a important piece, which is defining what the paths and pillars and things like that are, as the physical 3D or 2D representation of those.
Mhm.
That is not there in JEP30 today at all, right? And it ties to the MDK and possibly ties to the ADK as well, right? So I think the next step should be that JEDEC needs to take and absorb that into JEP30. And in parallel, we are working on test 2.0, which works off of that information, and we add additional stuff that's actually needed for the test flows.
Right. So I'm not comfortable where we're at the point where we want to present this yet. Bala's new, he needs to look at it.
Yeah.
We should have a broader audience look at it and give us feedback and say, is this good enough for Rev 1.0? Speak now, because once it gets into JEDEC, if we have to overhaul it and change a lot of stuff, that's not good, right? So I think we need to do a fun vote to make sure we're comfortable. This is a solid starting point, and then start the process. We could start building our test flows and actually start using it. And I'm not aware that we've done anything with this, right? So we did agree that, on some of the physical stuff and the MDKs, let's add it to the demo. So we, just do some kind of very simple, basic testing to make sure it's usable. I don't think we've done that. I think that might be a good thing to do on a very simple design, to demonstrate that it works, and then we can add all the bells and whistles later down the road.
Okay, so two questions about this. First, the first question you mentioned, this needs to be reviewed and to see to make sure it has the solid foundation. Who is going to be the person to review and make that call, right? And the second side to that is we need to iron out the relationship with JEDEC, right? The way it has been structured is it was intended to be structured as we work here, right? We create those specs, and then we publish it and hand it off to JEDEC, and they can absorb it. Right now, the question is, what does JEDEC's schedule look like for that? What are their plans, and so on, right?
Well, they're moving towards doing 2 releases a year.
Yeah, it's not only for the release, but for them taking this piece, right? And any follow-on piece.
Things, twice a year. So there's ballots, right? So
Yes.
So if you want to get something on the ballot, I don't know the exact process, but basically, we need to let Michael know, hey, we think we have something ready to go, and he'll let us know, the next window of where we can submit it. So
yeah,
if we're
it's not only
that what we have is ready to have that discussion, let's do it. But let's circle internally with all the concerned stakeholders and say, yeah, this looks like it's a good solid start. Let's get it in there and then continue.
Yeah. Just to give you a high level preview of what's in that spec is basically what we talked about last year, right? Identify modes, identify pins used in that mode, right?
Yeah.
Their test, right? Just the very basics.
Yeah.
And the other piece is defining what is a path, the 2D and 3D representation of that. That's it.
Okay.
Right. It's what we talked about last year. That became
You're
1.0.
a test bed for purposes of wafer sort, correct?
We can differentiate between sacrificial paths, other paths, but also the additional thing is the physical construction of that pad, right? Is it just a pad, just open pad on top? Is it like for hybrid bonding, or is it a pad that is has some 2D structure to it, right, with multiple layers, or is it a BGA ball, or is it a copper pillar with multiple layers in it?
Okay.
Right. This would be related to the physical aspects of this of tests, right? To know what you can probe and what you cannot probe.
Right now, you can probe C4 bumps, right? So a C4 bump could be a probe, or you could also have sacrificial paths for probe. You could do either.
That's
or.
right. That's right.
In our format allows that, correct?
Yes.
Okay. And that's essentially, I believe, all that's in the 3D block spec.
Yeah. I'm not sure
You're saying we can provide a little bit more definition of those actual physical structures for the pads and pins, right?
Correct.
Not
Correct. Right. You would use those, right? Once you assemble the 3Ds, you would use those to determine what the connectivity looks like, and possibly use those for mechanical analysis, stress analysis, and so on, right?
Right.
Right. So we needed that proper 3D structure. I don't
Yeah.
know if 3D blocks identifies the test pins in terms of modes and basic purpose of the test pin. I don't know that.
I don't believe it does.
Okay. So we have that additional information that clearly defines test modes, and even has the right, some of the test modes that are basically low pin count test mode that topic came about. It does support definition of that, where you would have 1 or 2 pins for all the test modes, and that's it, right? It says, hey, this pin is a low pin count test mode. Low, yeah, it's used in low pin count test mode, and then the test flows, or at least the engineer's responsibility would be to understand that, okay, all the programming or all the internal stuff happens to those pins.
Right. So David, you've looked at the P357 spec, right?
Yes.
Yeah.
A little bit, yes.
Still on 1.0, it hasn't been updated. So you're comfortable we have everything in there and more?
I think so.
Okay. So I think we should do that, right? Because in order to have interoperability, we want to be able to support that. But if it's just the me too, then why bother? But the fact that we have the physical stuff, I think that's kind of we need to go through that exercise to, what are we doing above and beyond what's in 3D blocks?
Yeah, so exactly. I think
So I heard one thing, but we should, is there other stuff in there that,
my understanding is at least that basic mode and pin definition goes a little bit beyond 3D blocks, and really we want to support the test instruction flows, right? Not only at the final manufacturing level, but even the entire development, right? Hooking up and things like that. And the discussion we just had about those fuses, addresses, and values, that's a natural extension to what we already have, and definitely goes beyond that.
Yeah, so that Yeah, that's a different type of pad, right? So that's like a high voltage pad, you know, stuff that's used for tests. So that might be something we do want to add in there. At least say, here are the test pins, and you know, this is the min max voltage or whatever. That might be something we can sneak in.
So so the question about that is, so the original CDXML definition already has a voltage level assignment to each pad, right? So that you know what voltages
Okay.
it is supposed to take, right? I don't know if JEP30 caught all of that information in there or not. That's something we can check. Right, JEP30 has a whole section on electrical properties on pads, and the question is, does it have pretty much domain assignments, right? We had the original CDXML does have a domain assignment. You say, hey, all these pins here are this domain, and all the other pins are that domain.
Yeah. So we
They're
can
not.
define a fuse power domain, right? If it's
Yeah.
general purpose, right?
Yeah. I think the way 3D Blocks and Intel were doing it is with voltage areas, which kind of makes sense. But I personally prefer the domain definition that
Yeah.
is not necessarily tied to a physical representation.
Right. That way, it's also a little bit more UPF friendly, right?
That's right. Yeah, you can have bumps all over the place, which are different domains, right?
Yeah.
And representing those physically becomes difficult.
Yep. Yep. Whereas if you define the domains in UPF, then you know that hey, all these pins are on this domain. Period.
Yep.
Yeah. Rather than saying this is the region, right? I don't care about
Yeah.
the physical guys worry about that, but
Yeah.
from
So
the perspective, you're not looking beyond the pin. So
that's right. So to your question, with regards to the status of TDK 1.0, I think it's in a reasonable shape, right? With our understanding is this is really the starting point, right? And then we're going to be working on TDK 2.0 and so on, right? But as a starting point to put all the um, basic information in there based on our discussions that we had last year, I think it's there, right?
okay.
If there is one or two things missing, that's not a problem, right? But as far as basis, this information that doesn't exist anywhere else.
So Paul, you have this, right? You have one that out. I sent you the spec. I know you've reviewed it, right? Did we lose Bella?
No, but Bella's on mute.
Sorry, I was talking in the mute. So Tony, which spec you are talking about? There is the TDK 1.0.
Yes.
Yeah, I think you said you will forward to me. Like I haven't got it, Tony. Like,
Yeah,
can you?
you have it. I sent it to you months ago. You reviewed it and gave a summary of it. So it hasn't changed. That's the latest.
Okay. Let me recheck that. I thought was it TDK? Okay, let me go back and double check it and get back to you, Tony.
David, maybe you could just, I mean, send the link in the chat or something, just so it can make it a little bit easier.
Mhm.
Yeah. Let me Bella posting link in the chat. Right. And again, the purpose of TDK 1.0 is to get the basics in there and then expand on that with TDK 2.0.
Yep. Okay.
Okay. All
All
right.
right.
Good.
Thanks, guys.
Talk to you guys later. Yeah. Bye.
Okay, thank you.
Bye-bye.
Bye.